Hello and welcome to the next lecture. In this lecture we will look into dates and times format in R programming and we'll discuss how to work with them. So let's get started now. I want to talk briefly about dates and times in R, which is a very special topic and could require a lot more time. And I have something I need to talk a little bit about how R represents dates and times and how you can use them in kind of arithmetic and date analysis types of computations. So R has a special way to represent dates and times, and they are represented using special data classes. So in the past we talked about different data types like lists and character vectors and numeric vectors, and so this is just another type of data on top of those kinds of classes. So dates are represented by the date class and times are represented by two separate classes, the POSIXct and the POSIXlt class. So dates basically don't have times attached to them. They represent a day and a year and a month, and you can figure them in a kind of a year, month, day format. So for example, this date is 1970 January 1st, and so internally the dates are stored as the number of days since 1970 January 1st. That particular detail is not very important, but in case you are wondering and you don't know how R actually does calculations based on dates, so times are stored internally as the number of seconds since 1970 January 1st. And so that's again another underlying detail. That's not very important, but it may be useful to know sometimes. So the way dates and R work is you can take a character string like this following 1970-01-01 and convert it into a date using as.date function. That's probably the most common way that you will begin working with dates. And you will notice that if you print out this object, you will get something that looks like a character string. Now it's not actually a character string, but it will print out that way because there's a special print method. Now if I unclass the object here, you will see I get the number 0. Remember, because the dates are stored internally as a number of days since 1970 January 1st. And since 1970 January 1st, 0 days from that point, you will get 0. Now if I input January to 1970, then you will see that underlying is represented as a number 1 because that's 1 day after 1970 January 1st. If you had a date that was before 1970, then they would be represented as negative numbers. So that's just for your little background. You don't have to worry about the underlying representation. Ultimately, what you need to know is that dates are stored as objects of the date class. Times, on the other hand, are represented as two possible types. One is called POSIXct and the other POSIXlt. So POSIX is a family of computing standards for how things should be done on certain types of computers or how data should be represented, and so there's a family of standards for how to represent dates and times, and that's part of the POSIX standard. So in the POSIXct class, times are represented as just as very large integers. And so it's a useful type of class if you want to store times in a data frame or something like, because it's like a big integer vector, while POSIXlt stores a time as a list and it stores a bunch of other useful information about a given time. For example, what's the day of the week of that time, what's the day of the year, the day of the month or the month itself. And there are a number of generic functions that operate on both dates and times that you can use in such. So the weekdays functions tell you what day of the week a given time is or a given day is. The month function tells you what month that date or time is, and the quarters function gives you the quarter number. So for example, quarter Q1 would be January through March, second quarter would be April through June, etc. like that. So these generic functions operate on objects of class POSIXct and POSIXlt or date. So for example, you can query things back and forth between POSIXlt and POSIXct if you want using the as.POSIXlt or the POSIXct function. So for example, the sys.time function here just gives you the current time as it's known by the system. And you can see that when it prints out in a year, month, day format, and then an hour, minute, second format, and then the time zone, which is Eastern Standard Time right now. So you can convert this to a POSIXlt using as.POSIXlt, and remember POSIXlt underlying is a list. So you can look at the names of the elements in this list. If you unclass it, and you can see that there's an element called seconds, that's the seconds, and the minutes, the hours, the M day for the day of the month, which in this case would be 24. The month is just the month, in this case that's a January, and then the year, the weekdays or the day of the week, the year, day, which is the day of the year, and then as.date for are we on daylight savings or not. It's daylight saving time flag, positive if in force, 0 if not, negative if unknown. So if I extract the seconds element of this list, you will see it's 14.34, and so this actually gives you the seconds in fractional seconds. So it's 14 seconds and then 0.34 seconds. So that's the number of seconds in the time. The POSIXct format, you can see that you can also get it from the as.time function, and you can see that if I unclass the POSIXct object, I get this very large integer because that's just the number of seconds since January 1, 1970. Now if I try to apply the list operator, the $sign to this object, you see I get an error because objects of POSIXct don't have these list elements in them. If you want to get those elements out, you have to convert it to POSIXlt using the as.POSIXlt function. Then I can get the seconds out. In this case, it's 14.37 seconds. So finally, there's a strptime function which converts dates which are written in character string format into date or time objects. Well, in this case, it converts into two time objects. So, and they use what are called format strings. So here I've got a string that says January 10th 2012, and then 10:14 meaning or 10:40, and then I have another string that said December 9th 2011 9:10. So if I want to convert these strings to time objects, I can use the strptime function. What I do is I pass the character vector and I pass it a format string. So in this case I got and so you will see how these % signs fall by letters, and then you can look up what these symbols mean in the help page for strptime. So %b means the month, %d is the day, then comma, and then %y is the 4-digit year, and then %h is the hour, sort of like colon followed by %m, which is the minute, and so that's the format of the times here. You can see that after I call strptime, I print out x, I get these time objects that are formatted, that are printed out in the standard format. When I look at the class of this object, you will see it's in POSIXlt format, and so that's the underlying kind of list format here. Now I personally can never remember what those formatting strings are, the %b, %d, %y. I can never remember what those are, and so I always have to look at the help page for strptime to remember what those details are. So it's totally normal if you too can't remember these details. You don't have to worry much. Now once you have got data in the date or time format, you can do operations on them, which can be very handy. For example, you can add and subtract dates, you can compare dates, you can see if one date is less than another date, or are these two dates equal to each other. So in the end, remember, you need to be careful that you can't always mix different classes. So for example, here I have x, which is a date object, and then y, which is a POSIXlt object. If I try to subtract the two, you will get an error because they are not the same type of object. So but if I convert the date x to a POSIXlt object, so I can do as.POSIXlt on it, and then if I take the difference, it will say that the difference is 365.3 days between the two. The nice thing about the date and time operators is that they keep track of very tricky things like leap years, leap seconds, daylight savings, and time zones. So just this first example here, you can see that 2012, it was a leap year, and so there was a February 29th. And so the difference between March 1st and the February 28th is actually a difference of 2 days, not a difference of 1 day like it is every other year. Similarly, I could take 2 times 1, which is my x, which is my kind of current time, and then y, which is in the time zone of GMT, means Greenwich Mean Time, and take the difference between those. So even though it looks like it should be a 5 odd difference, it's actually only a 1 odd difference because of the change in the time zones. So one of the advantage of using the datetime classes is that it will automatically take care of these kinds of irregularities. So that was just a quick some kind of overview of the dates and the time classes in R. So just to summarize, there are special classes in R that represents dates and times, and that will allow you to do numerical and statistical calculations. Dates use a date class, times use either the POSIXct or POSIXlt class, and then character strings can be coerced to either a date or a time class using the strptime function, or as.date or as.POSIXlt or as.POSIXct. The other thing to note that I haven't really talked about here is that a lot of plotting functions will recognize datetime objects. So when you try to plot an object that's a datetime class, it will recognize that object and then format the x-axis in a special way so that it will have a time element to it. So you might want to try to experiment with that a little bit to see how plots change when you use a datetime class. So that's it for today. I hope that you have learned what I tried to teach you here. And if you have liked the lecture, you can pay back with a like to the video and subscribing my channel, and also recommending this lecture to your peers. So see you in the next lecture. Ciao.